We're going to keep it moving here, guys, into part 2 of how to build ChatGPT. We're going to talk RAG and MCP connectors. Super easy, not that scary. Trust us. If you stick with us through this part of the session, you'll take your how to build ChatGPT to the next level with RAG. You'll also understand how to use ChatGPT connectors to basically connect it to large sets of documents in your Google Drive, in your whatever, through MCP, sure, whatever, but the docs is what you're here for at the end of the day. And you know, it's important to understand how to build this in because you're gonna do this. Like how to build ChatGPT for your job or for your client today has to start with high-level docs of some sort. And we can do like the classic RAG thing where we're just uploading a file, or we could also just say, take all my files. Now, of course, this isn't always good because in the age of context engineering, more isn't better, as it turns out. But, I mean, MCP, you know, so maybe it is. RAG connectors building. Let's talk about RAG just at a very basic fundamental level. Well, first off, RAG looks like here in the photos and files. That's RAG, okay? But also, it looks like connecting your Google Drive and using connectors, connecting your GitHub, connecting whatever, right? And this is super easy in the Responses API and super easy with MCP. We're no longer talking about what MCP is. We're talking about how to use MCP, and that's actually quite useful. We don't talk about what HTTP is, for instance, but we do use it a lot. So from first principles, we want to avoid these confident responses that are false. Just dead being lied to by the LLM. Very, very bad. Now, OpenAI recently defined properly hallucinations. Properly. Well, they defined it. That's what they said. They said plausible but false, okay? So pernicious, these hallucinations. But basically, RAG tries to solve this problem of fact-checking. We got to fact-check, just like we do with people. Hey, bro, you just lied straight to my face, okay? Where's the data where you would say something like that? Say the same thing to your LLMs. Make sure you're holding them to account, just like a great employee, just like any other agent. Find the references, add the references, get better answers. That's RAG. And so we do retrieval, we do augmentation, and we do generation. And that's really the whole deal. So, you know, again, the people who use our app don't care, okay? What they care about is that it's a great output and it's not lying to them. That's our job. So they look at it like this. But when we consider what's inside in RAG, there's the retrieval piece, there's the generation piece. And generally, you can optimize both of these pieces. But when you're talking about returning the right stuff into context, we're going to generally think about optimizing RAG first and foremost, because as goes retrieval, so goes the generation. I mean, information retrieval is not new, right? It is not new at all. It's the whole deal of building applications in the first place. Using LLMs just does IR heading into the generation. So this is all about giving the LLM access to stuff it wasn't trained on, to new knowledge, to stuff that's specific to your org, to the acronyms that matter to you, to your customers' information. Like the data is the gold. And everybody's got the same LLMs and frameworks. Nobody has your data. Nobody knows what you know about your customers. That new knowledge is what we need to do retrieval and put stuff in context with. And there's a number of ways to do that, but classic RAG is gonna, you imagine the question goes in, the question gets turned to a set of tokens. Those token representations are then turned into a series of numbers represented by vectors that we can use to search for similar vectors amongst all of our data that we've chunked up and put into our vector database. And so we're basically using embedding space to very, very quickly search our documents to return stuff that's similar to our query. We say something like use the provided context to answer the user's query. If we don't know the answer, LLM, please tell me I don't know, don't lie to me, don't hallucinate. Fun fact, from their recent what we learned about hallucinations. Apparently, they're not inevitable because we can train our systems to say, fifth, nope, not answering that. And maybe we should. Maybe we should do that. But that's really the only way you can avoid this problem for good, period. So it's important. They've worked with a lot of enterprises. I'm not sure you want to deliver that news to your boss, but you might want to build it into your applications and say, look at my hallucination rate. It's basically perfect. Then we return the stuff not in vector representation, but in natural language into the references. And that dense vector retrieval, sometimes sparse or hybrid vector retrieval, but vector retrieval nonetheless, feeds what we put in context. We're almost done. We've augmented after retrieval. We've got to do our generation. All this happens pre the actual model call, okay? Then we get our better answer, and we're happy. Essentially, we have this retriever piece, and then we have this generator piece. So when we think about building these applications, it's quite simple. We have the retriever, we have the generator. We do retrieval well, we do generation even better. And this kind of user just wants good stuff. We have to deal with the bad stuff. That's really important. That's this whole discussion of evals. That's this whole discussion of vibe checks. That's this whole discussion of how do I put guardrails on it? How do I not show this to my user? How do I get a human in the loop? The documents, the chunk sizes, the retrieval strategies, all this has the fine art to it. But if you don't know your data, you can't decide on any of this stuff. You really can't. And yes, there is some optimizing you can do in terms of the generator. You can say, well, if you say this word, don't send it to the user. If this is the thing that gets returned, don't do that. And you can put these very, very basic guardrails on just the generator from a prompting standpoint. You can also put more proper guardrails on. That's beyond the scope of today. But essentially, we're connecting users to the information we know they need, through this retrieval process into generation. Now, this piece, is it really necessary, though? This is the discussion of RAG is dead, long live RAG. Well, the responses API is like, no, it's not, because responses API, which is fine. Basically, just give it the doc, and it'll do all this for you. There's also some interesting things happening, on the limitations of dense vector retrieval, and how we're throwing things, over the wall to dense vector retrieval. We're throwing things into context, and we have these sort of limitations are coming up because people are beating this thing to death. From dense vector retrieval limitations to context rot, as we'll talk about a little bit later, it's just like, what does it mean for something to be relevant? Semantically similar via dot product similarity. We can get down into the weeds, but we don't really have to. We can just make sure that we're giving our apps access to the right information. And this is where connectors come in. This is where MCP comes in. You may have heard MCP. It's a thing. It's a standard for connecting AI assistants to the systems where data lives, content, tools, dev environments, connecting, right? It's about connecting. And this idea of connecting AI applications, especially like as you get started, when you set up your dev environment, when you set up Cursor, to the places where the information lives, information about your code base, information about how you do branch development in your org, information about your customers, information about where the databases are, information about how to query stuff in those databases, information about what's in your Google Drive, information about what's in your Slack messages. All that stuff you can kind of bake in to even a single developer's dev environment now. And so this is important because really you get a lot of this for free out of the box. So the question doesn't become how do I get more context into the context window. It becomes how do I retrieve the right context and how do I get less. We can also move stuff in between, and this is the whole USB-C of. This is straight from their website. That's always constantly updated. It's worth checking every once in a while. And so this, AI applications like Claude or ChatGPT can connect to data. Yeah, indeed. We already have seen that, and we can do exactly that We're connecting users to the information we know they want through our application. That's what RAG is all about. That's what MCP connectors is all about. That's what the Responses API helps us do. And so, back to, actually, this is now May 2025. We're adding built-in tools to the Responses API, including, you guys asked for it, everybody wanted it, MCP servers, and then image gen, adding more tools now. We're layering in the tools this year. We're layering in the tools. And we are actually getting better at RAG out of the box. You see that? That's dope. Okay, so you guys can be worse at it because AI is better at it. That's what I heard. That's how we're supposed to think about it. And so now we actually don't even need to do any of this crap. We can just give it the file and trust OpenAI. Am I right? Well, the Responses API would have you think exactly that. Maybe it's true for your application. Maybe it is, right? Maybe you don't need that level of security and fidelity, and maybe you can get it if you pay their enterprise plan. You can also get access to all of your stuff immediately. Will they see it? I don't know. Will they train on it? I don't know. Well, that's beyond the scope of what we're great at. So, Wiz, is it true then that MCP is basically just doing RAG? Oh man, is that a hot take, or is that like, I don't know, what's going on there?
I mean, it is most definitely not true that MCP is essentially doing RAG. Yes, unfortunately.
Dang.
Sorry.
Okay, all right.
Sorry, RAG. So MCP, Model Context Protocol, right, is a protocol that helps us connect things together, right? So even if it did that extraordinarily well, at no point is it doing something other than connecting things together. So MCP is really, really, really effective at helping us do RAG, absolutely, of course, and do it in a clean way and do it in a way that should work, across the board, and should allow us to do it in a way that allows us to talk to other systems that are MCP, that are also using MCP. But it certainly by itself doesn't do anything other than help us translate. It just does that extraordinarily well. And so it can be useful to enable more use cases for RAG.
So, but it does help us connect to the places where data lives. And RAG also does help us connect to the places where data lives, or it helps us connect directly to the data, maybe.
Yeah, it helps us connect our LLM to context, right? So any kind of context.
Model Context Protocol.
That's the whole thing.
Oh, yeah. Wow. Okay, coming together. Okay, then, so if we think about, let's say I have one file, okay? I can give the Responses API a single file, or I can give it access to all my files because MCP and because dope. Just look into Google Drive, find it yourself, AI. Why do I have to do this?
Yeah, I mean,
which one should I use?
I would think less of it in terms of volume, and I would think about it more in terms of, do I wish for someone to be able to connect their data source to my application, right? Or do I want my application to be able to connect to other people's data sources? Of course, for the case that we have the data source, for the case that we own the data, we should just build a system that works really well with that big old pile of data, right? MCP is useless middleware in that case. But for
strong
any
words.
Case, it is.
Wow.
But for any case where we want flexibility, or we want our system to neatly interact with a different system, that's where MCP comes in clutch, right? It's a silly analogy, but you don't need someone to translate for you to yourself. If you're talking to yourself, you certainly don't need a translator. But if you're talking to someone else, you might need a translator, right? And so that's how I would think about MCP. When it's internal only, then there's no real need. The moment that you want to connect to other sources of data or have that flexibility, MCP should be used. In this case, if I want my user to just upload one document at a time, I don't necessarily need MCP. But if I want them to connect their entire GDoc suite to my application, I most certainly want MCP, right? And that's the way to think about it.
Okay, yeah, and importantly, if we want our data to be easily accessible in a place where data lives for others, then maybe MCP is something to look at too. Okay.
100%.
Like, let's say something external, like even a single agent operating out there, not inside, but that needs to be able to hit my data, which is something that's less common than maybe just looking at your data and building a prototype app. Okay. Then we're going to get into the building here, just quick introduction, two-part demo. So we're going to use the Responses API to do both of these things, do file search, to do model context protocol, and to set up some MCP servers. This is just this piece here. We will build this UI. We will vibe code it again, 345, if you just came for the Vivity vibes. This is also like, you can put any of these in super duper easily. And this is all very, very straightforward to do. We'll have Q&A after Wiz's second demo. If you want to follow along here, go ahead and QR code. If you're still here, you're definitely somebody that might be interested in our Discord community, as we are on a mission to build the world's leading community for people like you who want to build, ship, and share production LLM applications. I see phones down. Here we go. They are, yes.
Yes, it should all be available on the GitHub. If you have any questions about running anything or need help, please do let us know, of course, and we'll be more than happy to do that. Okay, so the next section of the demo is similarly very straightforward from like a code perspective. I mean, again, these are great detailed concepts, right? Our job of like wiring it up, much less difficult than understanding the underlying technology, right? Classic APIs. So what we're going to look at is two examples. One is adding some datums, and the other is connecting something using MCP. Now, you don't have to worry about too much what like MCP really is under the hood. You just have to know that it's really good at helping us connect context. And we're going to start the notebook in the same way as always. Give your OpenAI API key. We're going to spin up our client, OpenAI client, same as before. And then we're going to create a helper function for us, which is going to upload a file. You're going to notice that we have this ability to upload a file. We can either do that through Bytes IO stream, or we can do that by passing the actual local file path up to the API. Now, for the use case we're talking about, we have set up some data, which is in the repo, which is basically these two different papers about embeddings. So that's what we're going to look at today. We can go ahead and upload the embedding-based data, which is talking about the limitations of dense vector retrieval, right? So the RAG v1, and so we upload it to OpenAI, easy peasy, and then we're going to create a vector store with it. Now, this vector store is very similar to what you would do if you were creating a vector store on your local machine. However, it's hosted by OpenAI. What this means is that there is a charge associated with hosting this data. It's very, very small for very, very small files. But if you were to push gigabytes of information, you're going to get charged quite a bit. So keep in mind that these endpoints are not free. You can't just dump whatever you want on OpenAI. They will make you literally pay. But what this does is it builds the thing that we can then query, right? So if you're familiar with RAG already, this is pretty straightforward. If you're not, the idea is what Greg walked through, which is that we have some pool of resources we want to be able to pull in whenever someone asks us a question. We want the stuff we pull in to be relevant to our question. The next thing we can do is add the file to our vector store. We're going to wait for that to process because it can take a while. Once it's processed, we're very happy. And now we can do basic file search. This is the first time we're going to see tools in the code. Now, tools are functions, right? So the idea of tool calling for LLMs is function calling. There's a lot of ways that this can be implemented. This is the way we're going to use it today, which is we're going to use a pre-built tool from OpenAI called File Search. Unsurprisingly, it is going to leverage the vector store that we created to search for relevant files. You'll notice that we directly call out the vector store that we wish to search. You may have many different vector stores, and they may be associated with different users, or they may be associated with different subject matter. And so you can imagine, trivially, that you could extend this quite a bit, right, to include multiple different vector stores, and you can imagine that that becomes an engineering challenge rather quickly. For us, though, we have one. It has one paper. Shouldn't be too bad. We create the response otherwise in the same fashion. We have our model, and then we have our input. The tools are determined by the LLM. Something else useful to know about this pattern is that it does not need to use the tool unless we tell it it needs to use the tool. What this means is that it may not use the tool. So for instance, if I asked a question completely and totally irrelevant to the file that I uploaded, there would be no need to use the tool, right? We only are going to use those tools when we ask questions about the documents contained therein. We have this query, and we get a response. Dense single vector embeddings have a fundamental capacity limit because of blah, 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 blah. This is basically verbatim from the paper. Good job, Rag. It did the thing. Next, we can look at the actual response. And you can see that the response that we get is a bunch. And it's not just the actual content or the final response. It also contains some citations. So it contains the parts of information that the LLM referenced when it made the actual response. Now for us, this is an entire PDF, right? So it's obvious, but if we had many hundreds of documents, you can imagine this is going to allow us to surface directly to the user, like where the LLM picked up this information. Citations are incredibly important for user trust. I'm sure you guys all are familiar with that. When ChatGPT had deep research mode, and you can just click the link to see for yourself what it said, it certainly made me feel a little bit better about what the LLM said, because I could fact check it. Same here. There you go. Okay. Once again, we can include some of those results in the response so that we can actually, pop this into the response output. Easy peasy. Next thing that we can do is we can look at the ways to modify our tool. One of the things we can do, again, is enforce the usage of it. We can also, what's called top K, right, from the RAG world. The idea being we can choose a number of documents we look at, so we can limit them or we can expand them if in the case that we don't want to be too confused and only look at the absolute most relevant documents, we can set this number quite low, as you see here. And if in the case we want to keep things a little bit broad, we can increase that. But these are some levers that you have. Others include metadata filtering. Metadata filtering is extremely important. This is going to allow us to do things like only look at responses that have X, Y, or Z metadata when you're looking through this request. This basically allows us to do like a pre-processing filtering stage. And that filtering could be incredibly useful since it's going to really limit the potential pool of documents. For instance, if someone asks a question about finance and we have metadata related to finance, we can filter only on those finance-related documents and not, say, get documents that are from another topic that may contain similar themes. So that's just a way to do that. And we print it out easy. And then, of course, we can add more stuff, and we can search through that more stuff. So this is going to add the rest of the documents in the data directory, so that we can now ask questions of all of our documents. And then, of course, we can look at many different documents. So we don't just have to do one. This is an example here. We can compare and contrast these two documents. Very cool. We love that. Let's go. Okay. Many different file formats are supported. All of the classic ones. You love to see it. There you go. Okay, so MCP. There are two ways of doing something similar to MCP. One is through connectors. Now, connectors are MCP servers or wrappers that OpenAI maintains. This means that we don't have to run them or we don't have to provide them. For instance, MCP server for the Google suite of tools is run and maintained by OpenAI. We don't have to fuss with that. All we have to do is provide our OAuth 2 API token, and then we're off to the races. There's also, though, however, remote MCP servers. These are servers that we could host. So this is, for instance, if you have an MCP server and you want to leverage it through this API, you can do that by pointing to it. It does need to be accessible by OpenAI, which means that it needs to have an exposed public endpoint, which means that you're going to want to make sure that you have a token to use it, that you're not just letting anybody use this MCP server. But the idea is straightforward enough. We can use either their pre-builts in the connectors, or we can use remote MCP servers. We love that. That's great. We're going to try one with their connector for calendar events. This is going to require you to get your OAuth token for Google. Instructions on how to do that are here. Very easily, all it does is you can see here, we have this tool of type, and then we pass in the type, and that's it. We call it what it is, we give it the token, and then we do something risky and say never require approval. And then we ask a question about our calendar. You can see here that it gives the response. So on Friday, September 12th, I had an event about GPU engineering. It was good. There you go. The idea being, though, that this is allowing us to connect our OpenAI Responses API with Google Calendar. And it can make searches on Calendar, look for events. If you want to get real crazy, it can create events and delete events and invite people to events. All of this is handled through MCP. You don't have to worry about it other than giving that Google OAuth token and having a lot of trust in the agent. We can also do cool things like exactly what we said, which is specify exactly what tools are allowed. In this case, if you're like me and you don't super love the idea of this agent system starting off by creating events for you, you can limit the tools that are allowed. So we do this by building an allow list. This means that we will only be able to search events and read events. You're going to want to use the same practices you'd use with any application, which is that we want to give whatever service is using our data the least amount of access that it possibly needs to get the job done. You get the idea. There you go. We'll scroll down. We love it. It did a great job. Next, what we're going to look at is an actual external Get MCP server. This does not require a token, but the idea is that this is not hosted by OpenAI. This is hosted by Get MCP. You can see the tools that we're allowed to use. Very, very limited in this case. But again, the idea is that this MCP server exists somewhere and is hosted by someone, and we can just attach to it. And it's as easy as including this tool definition in JSON, and then we get to do this thing, and then we can ask how tick token works, and Get MCP is going to tell us how it works, which is great. BPE, we love to see it. That's the idea, right? So all of this, all of what Greg was talking about, all of that yapping we did about, is MCP RAG and everything like this, great. The way we use it is we simply point to the MCP server. We include the authorization token if one is required. We build an allow list for the tools we care to use, and then we submit a request. Everything else is handled for us, thanks to the incredible work of the Anthropic team on building that protocol that allows that easy communication. So again, concepts, lots to learn, tons to know. Code, it's a JSON blob that says MCP, right? Not too bad. And with that, we'll go back to Dr. Greg.
All right, so we're going to do a quick Q&A, if you guys have any Q&A, so we can just hang out here. So I guess, Wiz, like the first question is, should we be using MCP when we build RAG applications?
You can, yeah. I mean, absolutely.
Other questions? Go ahead and just raise your hand if you have any.
Do
you? when you go to build a RAG?
Oh, no, for sure not.
What? What do you mean?
I like MCP for what it's useful for, which is allowing people to connect their data to my application. This requires me to build an MCP client, which is easier to do because it allows the user to bring whatever datums they should desire, right? I care much less about exposing my data than I do about allowing people who are using an application I've built to bring their data. MCP is incredibly useful for that for me. Otherwise, it's very useful for other people in many other ways.
Okay, all right.
I'm curious about your opinion on MCP versus OpenAPI.
So I'll be honest with you, that question befuddles me a little bit. But do you mean MCP as in?
Oh, they're just different tool calling protocols.
Oh,
right?
okay. Yeah, MCP is easily right now the standard for connecting context to models. I wouldn't think of it strictly as a tool calling protocol. I would think of it as a context protocol. Any protocol you use comes with gotchas. If you use something like MCP, which is right now probably one of the more adopted protocols for connecting resources to LLMs, you're probably going to have a more fun time than if you use something else that might require a translation layer or the user to have specific tooling. In terms of like, is one better or worse? They're all so you guys are, I think, newer to the field maybe on average. So I'm going to say something that's very provocative.
Oh yeah, let's go.
But I mean it with good intent. They're all terrible protocols right now.
He's done it.
We're in the really early stages of this, guys, and there's a lot of big problems with any kind of protocol we're going to use. A to A, MCP, things like security, things like protection against prompt injection, things like how insanely permissive some of these things are, or how easy they are to confound and therefore exploit, means that we're at like they're the worst they're ever going to be today, and every day beyond today they're going to get better and better. And you would still be early to integrate them tightly into your pipelines if you do so now. And so if you hear that and you're like, oh God, I'm scared, just wait. Soon we'll have more. Do you have a follow-up, sorry?
Oh, no. Thanks, Chris.
Yeah. So MCP, the S is for security, right?
That's right.
Okay. So this also reminds me, Wiz, of the kind of discussion even 2 years ago here. Everybody was like, LangChain sucks. I heard it was terrible, stupid in production. There's like 2 people that have a talk on it, and they're like, we tried it. Weak. I feel like we would see similar talks today if people said, yo, we tried MCP, stupid, weak, insecure, don't do it, waste of time. It's sort of the natural progression of things, right? Maybe 2 years from now, MLOps we'll see like everybody's using, well, maybe not that protocol if it's as garbage as you indicate, but maybe some protocol.
Yeah, MCP2 is going to be big.
Yeah, okay, yeah.
But yes, I mean, we're in the fastest growing technology field in a while, right? I mean, and the fact that we're using the systems that we're building with to build the systems that we then build with means that we're doing a lot of work very fast.
Danger zone.
And we're getting to prototype phase very, very fast, especially compared to earlier times. So I don't mean to say don't use MCP. I mean to say if you use MCP, please be very aware of the weaknesses, and it's going to take more engineering effort from you to shore those weaknesses up than it will in the future.
Okay, but you don't really mess with MCP.
I like MCP.
Yeah. We teach it in our course because people love it. They want it, But,
and I consume it. I have on OpenAI, I have the connector for my calendar. It is useful. You know what I mean? It's not like there's no utility at all. You just have to be very careful.
Okay,
and
so
safe.
MCP and RAG not the same, but is the future of RAG going to be MCP powered or similar protocol?
Certainly
powered?
a stream. Yeah, I mean personalized RAG, right? Where you're bringing your data, where you're bringing your
me.
Yeah, exactly.
GPT, right?
That's right. Yeah, GPTU will absolutely leverage something akin to MCP, if not literally MCP itself.
Okay, all right. Other questions? Yeah. Oh, God. No, not this guy. Okay. Talking to the mic, please, sir. Thank you. Thank you, Sean.
Awesome, Chris. Thanks so much. This is amazing. Quick question on the text to SQL. Is MCP, I mean, I feel it's more beneficial for text to SQL problems because I still see there is an authentication and authorization issue in MCP, which we can't able to still connect to different individual like team members if we want to, or filter it. There's something called teleport or something came in, and then which is helping. But how much do you recommend for text to SQL?
Yeah, I mean, anything that can be described well with a tool, you could then extend to MCP, right? So for text to SQL, there's definite utility. One thing that Ravi did mention is this idea of having a token, right, which enables some level of access management. And access management is obviously crucial for larger organizations that are building with these systems, since I don't want to be able to access something that I shouldn't be able to access, and most certainly my company does not want that. So I think there is some level of authorization that is afforded by using MCP, though I wouldn't lean on it for that in October 2025. Maybe MCP too. Yeah.
Cool.
Yeah, and it does seem like there's a real interesting use case throughout enterprises where they want to be able to get access to and return context that's relevant, but they want to be able to only return it to the right users, only return it sufficiently masked, only return it to sort of, again, the details of the context engineering are really coming into play as far as, we're hearing from people trying to build these systems. So I don't know that MCP is the layer that solves that problem, but like the S in MCP needs to come at some point, and I know folks care a lot about that. Probably at Toyota too, right? Yeah, okay. All right, thanks, Wiz. Thanks, Ravi. Thanks, everybody. Okay, we're going to keep it moving. Ho-ho! And we got agents for you. If you are still around, you are one of the people that is going to love our community. And if you'd like to talk about how we can help you guys, if you have a team that you're looking to train, or if you're looking to actually build, ship, and share anything in enterprise, I'd be happy to chat afterwards as well. Again, if you're looking to get started, ChatGPT can get you on that MCP train today. Okay, today. But when you give it access to all the tools, sometimes it doesn't know which tool to pick. Oof, we're back in the context engineering space. Okay, we're going to talk agentic search. We're going to define, if you stick with us for the next little sessionino, the next 45 minutes or so, you're going to learn exactly what an agent is. You're going to learn what exactly the pattern of agentic behavior is. You're going to understand exactly where we're at with context engineering in agents and multi-agent systems, the latest and greatest of what you need to know. And we're going to also understand how to leverage the Agents SDK. This is from OpenAI. This is the next layer on top of the Responses API. And we'll build, ship, and share something that's already in the repo, as you guys have noticed, the ones that are sticking around. In order to break down what an agent is, we kind of have to go pretty deep into stuff. And this actually continues to evolve, but we're getting some firm, real agreement amongst thought leaders in the field that we agree with, for the most part. We will continue to be persnickety and argue the fine points of the definitions, but for all intents and purposes, we can build, ship, and share stuff with agents today. Again, where do agents show up? They show up kind of here. We're not doing agent mode because that's a whole nother story, but they also show up. Deep research is one of the things it does. We talked about this a little bit earlier. It uses a reasoning model to sort of write the plan and then spreads out the team of agents, and they go off and do a bunch of parallel work. And that's dope. You can also build that from scratch yourself. But this agentic search thing, giving it access to the internet, giving it access to, you can give agents access to the metadata in your databases and let them reason and decide what to pick out. But in the end, these are all going to be tools. And so one of the ways that's the easiest way to think about this is we're giving the LLM access to tools. It's not new knowledge. We can also think of this as enhancing the search and retrieval process. This is a very, very stepwise way of thinking about this. We can sort of take RAG to the next level with agents. Fundamentally, we're using this reasoning action pattern. You'll see that it is deeply connected to where we started this journey in 2023 with function calling. We like to define agent at AI Makerspace specifically as a system that can leverage or emulate reasoning to make dynamic decisions in an application flow. Okay, it's very, very important because we're focused on building practical AI applications that create ROI for people and companies. One way to think about this is we're basically doing fancy RAG, okay? Not MCP. This is really kind of just doing retrieval and search and then putting the stuff into context and doing generation. Of course, we already learned about RAG. New knowledge, retrieval, in-context learning, blah, 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 retriever, generator. Agents now come into play during this retrieval and prompt construction or augmentation step. Therefore, we can sort of think of them as kind of this fancy RAG approach. We are doing this with access to tools. With an agent, if we give it tools, it can solve tasks, goals, problems, whatever we want to call it. We're now looping. We're now reasoning. We're now thinking, which tool should I pick out of my tool belt? Robin. The tool selection process is very important. This is the agent loop that we're thinking about here, where now we ask a question, the agent might deliver a response immediately to us. I don't need to pick up any tools. I already know the answer, boss. But hopefully that's not a hallucination, right? But it might need to take an action. It might need to take a couple of steps to figure out some new data to put in context to then get the answer. Now, the tools it might call are kind of coming into play in this action step. We can give it access to all of Google search. We can give it access to all of archive. We can give it access to whatever we want. In fact, one of those tools could be the little MCP connector directly to your Google Drive. Whatever we want really goes in here. We can write our custom tools. It can just be a Python function. All the tools we saw in Assistance API, all this falls into the realm of tools. We're going to get some result, some observation that we're going to pump back into our conversation thread, system user assistant status. And that's going to allow us to maybe have enough info to produce the proper answer. Well, this retrieval piece that we use this request response tool and function calling for, the tool is kind of up here. We're defining the tool. We're then actually doing the tool call, but the tool call to provide the response actually has to execute the code first. And to do that, we actually need to combine the reasoning and the action into one step. We do that with exactly our good friend function calling. So if we kind of zoom in here, we can see the reasoning and action part of this happening in this diagram. And if we kind of zoom a little bit deeper in and we think about this reasoning action pattern, this idea of tools in a loop, this pattern of agents, this tool calling is really just doing reasoning and then acting. From this OG paper, worth a read for everybody building agents. Reasoning traces, this is key when you start to do observability and you start to do evaluation, especially of agentic systems. Help the model induce, track, and update action plans. Actions allow it to interface with all the places where your data might live, and also any external sources, any environments. We're seeing more and more of this kind of environment-based speak with RL in these days, even in the MLOps agenda. So this fine-tuned model that calls the tool for us, what's really going on? Well, it's actually doing the react, the reasoning and action at once. That's called function calling. It literally, we already saw this earlier, right? The function calling itself is reasoning and action in a single step. The function calling itself is calling the tool. Function calling is a tool because it calls the function. Remember, the function calling API. We already saw this at the very beginning, if you've been with us from the beginning. Okay, let's go. These have been fine-tuned to both detect when a function needs to be called and to respond with JSON that adheres to the function signature. So reasoning action, react, boom, boom, function calling, you got it. So when we do the request response, when we call the tool, we set the tool definition, we call it, then we have to actually, to get the response, we have to execute the function code. We have to call the function. We have to do the function call or the tool call, whatever you want to call it. It's the same deal. So you'll just see in docs now, like from OpenAI, function calling and tool calling are the way agents, blah, blah, blah. It's like, they're just the same. We don't really care anymore about the details. So Wiz, question. We're talking about agentic search, which sounds dope. But is it just like calling the Google Search API? Is that all it is?
Yep. I mean, it's like there are some extra steps,
Yeah,
right?
okay.
But
all right.
but yes, it's letting the model call a search tool and then reason about the results it gets, and then either call it again or seek more information or be done. But the idea is that it is just giving access to a search tool to our agent, and then it will search for us. Yeah.
Okay, so, but it sounds like it's like agentic search.
Yeah.
So it's actually not that hard to build, as we'll see.
No.
This is a, would you call this a single agent system? Would you call this an agent with a tool?
Yeah.
Yeah.
I call it an agent.
An agent.
Yeah, it's an agent.
That sounds better.
It's
that.
an agent that does search. You know, there you go.
Right. No need to get all down in the weeds or something like that, right? Just
But
call
look
it
at the
an
code, and it's not more than agent plus search. You know.
We're just building an agent. Okay.
Yeah.
So, okay, easy. All right, thanks. Let's keep it rolling here. Let's talk about context engineering. So we talked about this agent idea. And of course, it's a system that can leverage reasoning to make dynamic decisions in an application flow. It's also giving the LLM access to tools. It's doing enhanced search and retrieval. It's using the React pattern. RAG was giving the LLM access to new knowledge. That's dense vector retrieval or sparse or mixed or hybrid. And in-context learning. Prompt engineering itself is just in-context learning. It's providing the instruction. And of course, prompt engineering is dead. Long live prompt engineering. But it has been subsumed in some sense by context engineering. And is this going to show up for us? Yeah. So you can start to see now, right? RAG, it's inside, right? Instructions, system prompt, it's inside. Structured output, it's inside. Tools, they're inside. State and history and memory is inside. Even long-term memory, cross sessions even, it's inside. Dang, that is a lot of stuff. It is hard to think about how we're going to do that right. For sure. It is hard to think about how we're going to build an operating system for our companies and for our clients. One that it leverages prompt engineering, it leverages RAG, it leverages agents, it does this in an intelligent way, it doesn't screw up the context. As we're starting to see, right, this is you know, it's all about the right stuff at the right time. Very delicate balance in these context windows. As people like Cognition will remind us, there's a great image there. I swear, it's really great. Don't build multi-agent systems is the blog from Cognition AI. They're building Devon. They acquired Windsurf, right? Scott Wu, what a legend, that guy. We heard earlier today in the keynote that the agents are beating the competitive programmers. Well, the folks at Devon are just a bunch of team of the world's leading competitive programmers that decided to build AI agents to beat the competitive programmers. It's getting crazy out there. They know the most about context engineering because code has been taken the furthest with the autonomous software engineers. And code is a very particular brand of operating. It's very less loose than general language. The folks building coding agents, we can learn a lot from them. This is one of the things that they're talking about all the time. But we're talking about agents, Wiz, or agentic search, or an agent with a tool, or just an agent. Okay, just agent. So I don't see agent in this diagram, though. Why not, okay? Is an agent above this, or is it within the tool? Where's the agentic exactly here?
Yeah, I mean, so all of these things effectively are what agents are built out of, right? So, available tools, available to what? Well, to an agent. Long-term memory, well, long-term memory for what?
An agent.
An agent.
Oh.
User prompt for an agent. You know, I mean, not every single one has to be part of every agent.
Oh, no. Okay.
But, these are the constituent parts of agent. I mean, context engineering is a process that helps us build good agents. It's not like agents are a useful tool to context engineer with just yet. I imagine that'll change in like 6 weeks. But,
it's the little back and forth of the agents and and so when you say agents in that context, we're getting we're spinning up the levels here, guys. What are you talking? You're talking about the coding agents that we use to build the sort of enterprise docs agents.
Sure. Yeah, any agent. All of those bubbles can impact any agent. Agents definitionally almost have tools or something close to tools at least.
That's what I heard.
They should have things like memory, right, or state. And all of those are axes on which we can engineer a system that provides the most appropriate context for each interaction. So it all rolls up to.
Is this just
agent.
one agent or is this multi-agents?
This is just the broad concept of agent.
Oh, wow.
So yes, the answer is most certainly.
The answer is yes.
That's right.
Okay. I think we have a summary of everything you just said on the very next slide.
I hope so.
Said by the guy who coined the term context engineering himself. Thank you, Wiz. It is true that everything that makes agents good is context engineering. All right, there's a one-liner for you. That should sell some consulting work or the new project to the boss right there. I want to do agents. I want to do context engineering, boss. You see, we got to think about what happens when we run these damn things. We've been talking about like 1, 2, 3 kind of runs. It's like when we even use an agent a bunch of times in a row, it's literally just churning up more context. It's having a conversation with itself. Like, when do you stop the session? How do you maintain the session across the other session? How do you know when to just restart the whole thing? You know, we often get started with people coming into our boot camp, and we make them do what we call the AI Engineer Challenge, and they build their first end-to-end app. And a lot of times they'll send us stuff that, they'll attempt to have a conversation with this really dumb app that they built that has no memory. It's just an API call and then another API. It's like, hello, and then it's like, oh, hello. It's like, and it just has no memory at all. But if we want our apps to be useful to people, and we even just stick in this single agent context, a conversation can unfold between an agent and the user, or it can just have the agent there running in the background, and it can be basically conversing with itself. It's like us thinking in our own head. When have we thought too much? When is it time to freaking go to bed, and just like refresh the cache? And we got to think about agents in the same way here. And this is where this conversation thread piece is so important, because like there is a dream, there is a promise of agents, and this kind of very simple rules and tools to add up to very complicated, very complex behavior, this richness of complexity, this is something that might just work. And this is the whole, like, you know, if you're kind of a doomer, it's kind of terrifying, but if you're very optimistic like we are, like it could do incredible things for the world, right? And if we inspire the right people to build stuff that makes things better for other people, then, you know, actually we're in a pretty good spot. But at the end of the day, we don't want to build it for the sake of complexity. We don't want to build it for the sake of looping around and adding more context. We want to really, really dial in how much complexity we need. So when do we need an agent, right? Well, of course, if your boss said, we're going to be agentic AI this year, you need an agent. Okay, but that's not ROI, because the chickens will come home to roost next year, if not this year. When you need the brain to figure out which way to go. If you don't, then it's fine. Just write the damn workflow like before. And this idea of workflows versus agency is getting a lot of buzz. Agentic systems, people like to say it has workflows, it has agents, and everything in between. But, you know, sort of, if it's a pure workflow, it still has some level of agency. You know, if then is some level of agency. And then if it's a totally agentic thing with full agency, well, first of all, don't give that thing access to you know, any of your systems. I mean, one of the things that I was struck by even in our organization is, like, there are very simple things I need people to do after our online events, right? Very, very simple things. Like, I've actually had my daughter, I could pay $20 an hour, do some of these things, okay? Now, I need a human there. Because I can't trust a freaking agent to log into my YouTube account, to log into my LinkedIn account, I'll never be able to trust a freaking agent to do that. I mean, I'm never going to say never, but, like, I mean, you know, it's like, it's worth $20 an hour, right? And so there's a lot of these things that, like, I think we really need to break it back down to what's really needed here, right? Do I really need the dynamic reasoning to solve the task more effectively than a simple workflow? More effectively, do I really need semantic search on top of keyword search? You know, and this is where we get into this discussion of, well, we have only talked about one agent. What about multi-agents? Now, I'm just going to get super meta for a second. This is the text. So maybe you guys have read the Doomer text from Stuart Russell. It came out a couple years ago. It was a dope read. This is the text on AI. AI itself is defined in this text as the study and design of rational agents. And when we're talking about agents, as we discussed, we're talking about agentic reasoning. We're talking about the pattern. We're talking about React. We're talking about the agent loop, right? We're talking about tools, search and retrieval. We're talking about a system that can leverage reasoning to make decisions in an app. And so when we talk about multi-agent systems, we're talking about a system that can leverage reasoning from multiple independent agents to make dynamic decisions in an app. And so the question comes, why would I need more than one agent? Well, let's extend our discussion of single agents. Do I really need dynamic reasoning to solve a task more effectively than a rigid workflow? Do I really need several specialized dynamic reasoning machines to collaborate to solve the task more effectively than a single agent could? Another way to think about this is, do I have too many rigid workflow if, else statements? Before I build one agent, I probably should have those. And then before I add another agent, I probably should have those. There's one caveat, and it's related to context engineering. You see, multi-agent systems are very good at separating tools, responsibilities, specific jobs, let's say, to be done. You can have better conceptual models, all this stuff, that's fine. But separating these functions, not just functions of the tools themselves, which, yeah, separate those, but also like the functions of what you need your agents to do. We kind of start to get into this weird overlappy space when we talk about functions sometimes, but multi-agent systems really are just function calls all the way down. And so it's like, how do you sort of think about leveraging this in an intelligent way when we get into this metaverse of multi-agent systems? And this is where, if you look across all this crap that you see out there, you'll see all these different design patterns, and it'll make you all excited about these different levels of cognitive architectures and these different levels of agency, and you'll have this idea of workflows versus agency, and you'll have different types of workflows, and you'll have different types of agentic patterns, and everybody will be telling you LLM is a judge, and evals, and scaling stuff out, and it's like, all that's fine. You can have supervisors, and you can have swarms, and you can look at what Landgraf says, and you can look at what Andrew Ng says, and you can look at what all these people say, and you can put all this stuff together into big lists, and you can feel good about all of the stuff you know about agents. And it's like that's dope, I guess, but have you made any cash on this? Are you actually delivering a better experience to your user when you go from a single agent to a multi-agent design pattern or workflow? Or are you actually just kind of like everybody else using these two types of things that started as consulting projects for many of the large language model companies, became features in their core product that everybody uses now, and now get used on a daily basis, and you're just doing business as usual with access to these tools. And as we heard earlier, even in today's opening session, from putting the human back in AI guy, right? It's like people are starting to get a little worried. Oh my God, how would I even do my job without AI now? It's like, without the deep research, or the searching and researching. The agent I'm already using, right? It's augmenting me. So we need to think deeply about how our users are going to actually get the great output they want from our apps. And we need to think about our role in getting from bad to good to great. And this is where we have to return to this idea of context engineering, okay? Remember, everything that makes agents good is context engineering. So there's some emerging stuff happening that I want to tell you guys about. First thing is, we have an acceptable definition, according to the man, the myth, the legend, Simon Willison. An LLM agent runs tools in a loop to achieve a goal. Wiz let us know that agents are loop riding tool using LLMs. Indeed, they are. And you can get into the details and be very technocratic about this, but Simon finds it useful because you can look at something and you can say, that's an agent, that's not an agent. We can talk a lot about ways people have defined agents in the past. This is a little survey of what does an agent mean that they put together for the AI Engineer Summit this year. And Simon kind of drove some of this along with Swix, if you know these guys. They're the kind of guys that get invited to the GPT-5 launch and live streamed on YouTube. Now, it's interesting if you dig into how many definitions people have messed with and how kind of not that useful some of them are. And then, if you dig into some of the kind of, we're looking for leadership out here. We're looking for thought leadership. We want somebody to tell us what the answer is. The problem is nobody knows the freaking answer, right? So the LLM labs doing their best. Anthropic comes out, they say this, everybody latches onto it. If you want to go through and learn what every single agent framework says, if you want to go deeper into some of the stuff we've done in the past to cover some of this, we've covered every agent framework there is on our YouTube channel. It's like nobody has the answer. We have a definition here. We have some more stuff here that we've talked about already today. We also have a really simple idea. We can extend RAG with agents. We can basically try to do better at models not hallucinating so much by doing retrieval and doing generation. by connecting users with information we know they want, okay? And so what happens when we add the loop of an agent is we go from this kind of very simple directed graph approach of RAG, and then we start to just kind of replace this with a tool. We start to just augment our retrieval with agents, let's say. And so we go from this simple API call, that's what we learned at the beginning of today's session, to a simple RAG, which we're sort of building out with the responses API, to some of these ideas that you get from Dex Horthy, the coiner of context engineering, the term. My biggest takeaway when I started learning about agents was that you get to throw away the DAG. What does it look like? Well, it looks like I don't have to do all the if-thens. The agent gets to decide how to get me there. That's dope. I give agents access to tools. They magically solve the problems. We've already talked about this. We've got the agent loop. We've got the reasoning action pattern. We've got how the tool calling in a loop is like the agents in the loop. We've got Simon reminding us that an LLM agent runs tools in a loop to achieve a goal. As for the in a loop bit, that's a shortcut for saying the LLM harness spots a tool request, executes the tool, and then calls the LLM again with the result of that tool. We've talked about that as well, right? That is our little function calling, beautiful stuff we know and love so well. So we kind of get to this place of context engineering, of everything, of this is just the right information at just the right step, of we want to be careful of context management and doing it correctly. We get to remove the DAG. And when we remove the DAG, do I have too many if, else statements? At a higher scale, we have some implications. And the implications are like actually long context is dumb, short context is dope. Actually keep the context as small as you can. Optimization means minimization, classical optimization. This is pretty intuitive. If we threw a bunch of garbage into the context window, do we really expect it to work out? Turns out reliable agents mean constructing great context. And it also turns out that even if we want to start securing our agents, and this is some relatively new research, one of the ways we can make our agents more secure against things like prompt injection attacks is we can minimize the amount of context we actually put in. So it's like literally from a performance, from a cost, and a security standpoint, it's dumb to put just a bunch of context that doesn't matter. So the question is, well, what context matters? And there's also really fun stuff people have done, like on context rot. This is such a great term. Shout out to ChromaDB for coming up with this. They basically made the LM say apple, 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 and then they got to the point where and then there was like apples, and then it was like apple, 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 and it just said keep saying this over and over, keep saying it. And at some point, about 5,000 tokens in, when you just have the thing doing the same crap over, it says, oh, gosh, I'm tired. I can't do this anymore. I need to take a break. And it literally turns into this like freaking human worker. I thought you were an agent, my guy. And like we get this weird degradation of performance on these LLMs at very, very high scales. And of course, as we can learn from the coding agent people, like over time, context becomes long, period, by running our apps. Like, it just will become long. If you're running a production application, context engineering is not a thing that you do in prototyping. It is a process that you are constantly doing in production. This is this idea of agile software engineering, right? We need some agile meetups for our context windows every freaking Monday now. And this is like the real deal of what it's like trying to run these things in production. And so, there's a couple takeaways from this. Own your damn context, minimize your damn context. That's going to be something like optimizing it. Actively manage it over time. Don't give it away to the AI gods. They're not going to figure it out. And it's like, literally, it's not even just garbage in, garbage out. It's like if you put too much garbage into that thing, it's actually unsafe. Like it's actually unsafe. Too much trash. So let's switch gears a little bit. And let's build something. Okay, this is going to be our last demo of the day before our last demo of the day. We're going to do the vibes next. Okay, so all you sticking around for the vibes. This is the Agents SDK, and the Agents SDK is something that started with this Swarm experimental educational October 2024. They replaced Swarm with Agents SDK. And this will make a lot of sense to you guys now, knowing everything that we know, okay? There's two ideas in Swarm. There's routines and there's handoffs. Quote from the initial release blog. And this is when it was kind of being figured out in 2024. And we'll actually throw one of these away in just a moment, but stick with me. So a routine is just a set of steps. It's not really super well defined. A routine is just a list of instructions and the tools necessary to complete them. And actually, this thing, a list of instructions and the tools necessary to complete them, was renamed to, you guessed it, agent. That's it. An agent has a routine. And a handoff is just a routine. An agent just handing off to another agent because it's a handoff, like getting transferred to the other agent on the other line. And so if we define a handoff as an agent handing off to another agent, we're kind of in this multi-agent pattern space, okay? But who cares? Who cares what the hell we call it, okay? You can fall down the rabbit hole caring about, is it a single agent? Is it a single agent with a tool? The fact that it has two tools, does that make it a multi-agent? And you can fall down the space that really doesn't help you at all. So an agent is going to express some intent. It's going to reason. It's going to think, do I need to make this handoff? And then it's going to make it happen. It's going to reason, and it's going to take some action. Classic agent status. And so to do this, we're going to leverage the Agent SDK. And this came out in March, about 4 months later. And they said, we're going to try to make this better than anything else that's out there. Enough features, works great out of the box, and you'll see some of these main features that look pretty similar to us now. Agent loop, handoffs, function tools, literally the classics. And then we got some core constructs. We don't really need to worry about guardrails. Those are pretty straightforward. You can check out more of our content online if you want to learn about guardrails. But we have agents and we have handing off to each other. And that's literally all it takes to build with the Agents SDK now. It's not routines, it's not the set of steps, it's not the instructions, it's not the tools. We just call it agents. Is this good enough for you guys to build production LM applications? We'll talk about it, but literally Wiz is going to whip up a multi-agent application right now. You can find it directly in the GitHub repo with a calendar agent, an event analyzer agent, a research agent, a preparation guide agent, and an orchestrator. Obviously, we need every single one of these agents. Very, very crucial for this application. When we come back, we're going to put all of this together. If you want to follow this, it's up here. We're going to put all this together, and Wiz is going to wrap it in a front end. He's going to vibe code the front end. He's going to show you the Vibity vibes that you've been waiting for. But of course, that doesn't bring in the dollary dues, prompting, RAG, and agents like we've been doing, like you guys that have stuck around the whole time. That's what really generates the ROI when you do it right. So Wiz multi-agent, calendar, research assistant, Demo 3, let's go.
Yes, let's go. Okay, so we have the next part of the demo. The big thing for this one is pretty straightforward, which is that we're going to use the Agents SDK. The Agents SDK is just like the Responses API, but for agents. Now, what that means is, sorry, do you have a question? Get that mic, bro.
So I wanted to ask a question based on the first part. Before we moved on to Agents SDK, we talked about using minimal agents as possible to not over-engineer and create more complexity than needed. But then we also talked about having minimal context per agent to improve performance and to make sure that we're having good results. How do you toe that line between adding multiple agents per either tool or per category of context while not over engineering?
Yeah, I mean that's
Literally, that's like the best question, and like I think everybody's asking.
yeah, it's nearly impossible to give a general rule, but what I would say is that before I would expand to the next agent, I would make sure that I'm failing on some case with my current agent, either due to context being overwhelmed or there's a clear division of labor that we can find between these two agents.
Okay.
You want to grow from one to many as opposed to start with many.
Yeah.
And that sort of helps grow into a situation where you don't wind up in over-engineered land.
Yeah.
But in reality, this is going to be very different if you're working on an agent system that's interacting with a consistent source of data versus if you're building an agent system that's got a lot of autonomy and reaching across a large number of tools.
Yeah.
We want as few agents as possible, but as many as is needed.
Yeah.
Which is, of course, a very difficult balance to achieve. So,
And
think-
each of those agents should have as few tools as possible,
Yes.
but as many tools as needed.
yes.
Yeah. So I think your answer of saying that until you fail, when you start to get below that, performance percentage that you would like, or you're not getting the correct answer, or it's too slow, or whatever that performance metric is, seeing if you can have that division of labor, see if there's something that makes sense to separate, and if you can separate the context that each of those things would need, and then that's when you decide to add.
Yeah, I let your agent pipeline grow, not organically necessarily, but let it grow from
failure.
a simple state into a complex state, and then aggressively prune back to simple as hard as you can.
Okay.
Yeah.
Thank you.
Yep. And this is kind of every application, unfortunately, right now that involves LLM is we just want it to be as simple as humanly possible. And the only reason we want additional complexity is because we must have additional complexity. And there are a lot of tools to manage state or manage context that don't involve splitting it between agents. So we'll keep those in mind as well. Okay. So code, once again, we're going to start with OpenAI API key. You'll love to see it. Also, Google Calendar. Spoiler alert, we're going to see it again. Okay. Then we're going to do a wall of imports, level wall of imports. Next, so in this notebook, you're going to see all of these notes that say note context engineering. This is all of the points that we care about context. You're also going to notice that this appears basically in every dang cell of the notebook, okay? And this is the beauty of context engineering. It's everything that we do. Like we kind of talked about earlier, if you're interacting with code that an LLM can use, you're going to wind up doing this as you're building. So the first thing we're going to do is build some pydantic models. These pydantic models are used for the same reason that we used them earlier. There you go. We have one for our calendar event. We have one for our research topic. We have one for our event research. one for our preparation item, one for our preparation guide. So the agent we're going to build today is going to allow us to prepare for events that are on our calendar. So events like perhaps a workshop occurring at MLOps that you're attending currently. The first thing we're going to do is create a calendar agent. We're going to use MCP, and we're going to use the hosted MCP tool. MCP is a great tool for context management, right? It allows us to ensure that we're getting the right chunks of data or the right pieces of context into our application at the right time. Thanks, MCP. What a baller. Okay. The way we actually integrate this is by building our first agent. It's extraordinarily complex, as you see. We have to first type the word agent, and then we have to name it, and then we have to give it instructions. That's it, though. I mean, this is in fact not at all complex, right? This is the way to do it. Everything's written in natural language. It's very straightforward. Is this a simple use case? Absolutely. Does much change outside of writing much better, very concise prompts and gluing things together in a different way? Also not really, right? This is the core construct. The idea is we say agent, we name it, we give it some instructions, and then of course we give it a tool. Now this tool is exactly the same pattern we saw in the responses API. It's literally the same. It's the same words, it's the same fields, it's the same. So we've already got this pattern. That's because under the hood, of course, Agents SDK is powered by Responses API. So we're just passing through to the Responses API. And then, of course, we're giving this thing a brain, and that is going to be GPT-5, because that's what we've used the whole time. And that's it. So now we're going to do this many times in a row, right? The next one we're going to do is the Event Analyzer agent. Now, the first thing that we need to keep in mind between these agents is that all of them are going to see their own separate context. And we're only going to pass between them the final result or the previous state of another agent, right? And what that does is it pairs down the context that each agent sees. So our whole system will see quite a lot of context, but each agent or each LLM call will have a relatively small amount of context. And the reason we do this is because, again, we don't want our context window to have anything other than what is exactly needed to take the next step. Now, the way we're doing that, instead of just saying, well, let's pass the conversation history in, we're using those pydantic data models to store information that's relevant for the next step, and then we're passing those forward to each step in our agent chain. And that's it. As you can see, we're doing a bunch of other stuff. You're going to notice a lot of this stuff is feels real similar to prompting, right, or prompt engineering. And it absolutely is, right? Context engineering is a superset of prompt engineering. Everything you ever learned for prompt engineering is applicable to context engineering. There you go. Structured output, you best believe. We don't want just loose, free-form, useless text, right? Terrible. So we're going to set up the next agent. Once again, we set up the agent, we name it, we give it instructions, this time a bit more verbose, we give it a brain. And this time, we're going to say, you can reason a little bit. We're going to get a medium reasoning capability, largely as an example, and just to show you that, once again, we're just passing this stuff right through to the Responses API, right? We've already talked about this. It's no different here. It does exactly the same thing. And then we're giving it an output type. That output type is that constrained generation. It means that instead of just a blob of text, we're going to get a data model, which is much better. Next, we're going to use a wonderful tool, which is web search. Once again, we name the agent. We give it instructions. We give it a brain. Look how crap this brain is, right? GPT 4.1, what's that, 6 months old or something? And then we're going to give it a tool, in this case, web search tool. Web search tool, it searches the web. That's all it do. And we don't need a crazy powerful model to search the web for us, right? We don't need high reasoning mode to do a bunch of Google searches, which is why we can get away with a small one. We also know we're going to do this a lot. We know we're going to do it many different queries. May as well use a fast small model and then let our big boy models deal with the rest. Something else you're going to notice is that we are requiring this agent to use the tool. Because what may happen is our agent, clever as it is, may say, bro, I already know this, right? Like you can ask it, hey agent, tell me all about Fast API. And it's like, I know all about Fast API. That's in my corpus. I'm confident about it. And I know the Fast API from like July 2023. Totally useless to us, right? So we're going to force the agent to search the web every time in order to ensure that it's not just hoping it knows and giving us some out-of-date answer, or worse, just making stuff up. Preparation guide agent, same thing. Because we're going to go ahead and make this like a coach, we've decided to use high reasoning setting. That's it. Same as the other agent. Calendar research orchestrator. Look at this bad boy. We're going to wrap a class in it. This is going to help us glue all the pieces together. Right now we have a bunch of agents and they need to be tied together. Our orchestrator does this. You can see that we have some methods here like research event, which is going to use the SDK runner to run our analyzer agent and then get some final output. That event research is then going to be passed to our next step, and on and on and on and on. Notice that what we can do is we can do things like for topic and event research.research queries, because we know, thanks to our Pydantic base model, that our LLM has provided us with a list, right? So we don't have to fuss around and parse out a list, and then if the list is valid, we can do this. We have some assurance that the list is going to be valid due to the fact that we set up the Pydantic base model using some async IO classic. There's notes on everything that's context engineering. We're going to run the guide agent, and then we return finally our big blob. We have a research and prepare for date method. All of this code, you can read this code. I don't want to bore you with every line of code, but the idea is that we can then use this system to research an event by using our calendar research orchestrator. We're going to look at an event from today. This is from a few days ago. And we're going to look at a talk we did with Maven on context engineering for agents and multi-agent systems. Very similar to this event, you might imagine. And you can see all of the things it said to do, questions to ask, everything like that. We love it. Use this to prepare. Boom, thanks, useful agent. And then we can do that for specific dates as well. But the big idea here, just to scroll back up to the orchestrator code, the big idea here is that all we've done, right, is set up some agents and then assign them a workflow, right? We're going to pass one agent's output to the next agent and on and on. So earlier when Dr. Greg had up that, that curve that showed us the kind of gradient between workflow and agent, right? This is a workflow that contains agents, right? So we're getting kind of a best of both worlds situation. That's the big idea with this notebook. We're just constructing this system. It's not like the simplest use case, right? It's going to look at your calendar event. It's going to tell you how you should prepare. It does that by searching the web. But it's not a lot of lines of code. It does a great job, right? And that's kind of the power of the Agents SDK. And we can manage all of this context at every step in code, right? This line of code is context engineering. This line of code is context engineering. This line of code is context engineering, right? The whole kit and caboodle is context engineering. Every line we write, we should think about how does this impact the LLM when I'm working through this workflow. We want to try to make sure it's as easy as possible, as unambiguous as possible. There you go. Back to Dr. Greg.
All right, so you're saying that's context engineering?
That's context engineering.
Okay, all right. Do we have questions from anybody? You guys got any questions before we get into the vibes here? Got some cues?
Got a cue.
We got cues. Hopefully
Let's
we got some
go.
A's.
Good question for you, Wiz. It was a great presentation. I missed the part where there's a context engineering piece. Is that separate or is it all embedded in each prompt? I must have missed it.
Everything is I know it's not useful to say, guys, but everything in the notebook is context engineering, right? The way we set up the agent, context engineering. The way we set up tools, context engineering. The way we glue all of the agents together, context engineering, right? The idea of building an agent is all you're really doing is you're engineering context around, right? You're choosing what goes into the LLM's input when, and then you're choosing how to handle its output, right? So the whole thing is, it's baked into every line. The notebook has like little blurbs that talk to each specific instance, but the idea is that every single part of the workflow, every single part of the agent. Like I said, whenever you type, you should think about how is this going to impact the LLM, right? That's the truth of context engineering. We kind of can't escape it. Yeah, but great question. Yeah,
Wait, so it's just prompt engineering then?
and more.
What the hell?
And more.
Do we just dupe everybody into this? What?
It's prompts, memory.
I wanted to be a
attachments.
context engineer, Wiz. Like, is it going to be a job title or not?
Oh, it's going to be a job title.
Okay, all right. It's coming. 2026, you guys. It's coming. Okay, so we covered a lot of ground with agents there. And, there's a lot of stuff you can do on the back end that we've been doing today. And I just got, connected with one of our most recent community members that took a selfie with me. That was dope. Join the Discord. We'd love all you guys to do the same thing today. Agents, lots of stuff. Make dynamic decisions, build apps, access to tools, get better at RAG, do function calling, be dope. All of this is cool. What we want to do is want to kind of back up like 100 levels real quick. And vibe coding, I think Simon Wilson was putting out today, vibe engineering. And then it got shut down by the industry. Vibe engineering is dead, I think, on its first day. Failed to launch. But like the idea of being able to create a really easy to use front end and the idea of being able to actually get this in front of users is so important. Because if you're just sitting there building by yourself, I mean, you don't know what the hell is going on. You got to get this thing out into the world. You got to show your boss, even if it's something where you're literally just showing him on your laptop because it's a work laptop and it's got a quick user interface and he can just kind of test it out real quick. This is you might call this on-prem, if you want to be fancy about it, but it's just literally like no, we don't have to wait for like the data transformation to take place, guys. Okay, let's just freaking do this now. I'll just keep it on my laptop and I'll show you what I can build. We don't have to give it to anybody. So this is a really super valuable skill, it turns out. And I want to I ran out of Canvas slides on one slide deck because apparently 500 is the limit. We've been here a while. Okay, hopefully it's gone by quick. We'll start at the end here with the conclusions. No, I'm just kidding, but these will be the conclusions. We want to talk about how to actually, now that we have an app that's worth showing to somebody, how to actually show it to them. And, we'll have a little bit of fun here because it's the end of the day, right? I know. We'll hopefully bring the vibes for you guys here. We want to now build our Chat GPT, right? It's really easy. It looks really simple. How do we do it? Well, let's first think about how we do it in today's world. So let's talk about vibe coding. Obviously, Andrej Karpathy, the man, the myth, the legend. It's not really coding. I just see stuff, say stuff, run stuff, and copy paste stuff. And it's like, yeah, dope. You guys may have seen Rick Rubin, what a legend. He put this together, Way of Code, when this first came out. This is we can have some fun this afternoon, right? Rick was like, yo, I read the Tao and it changed my life, right? Thus, the vibes. And it's called the Way of Code, right? The book of the way. So the Way of Code, that's what he put together. A dope piece of work here, if I do say so myself. When we recognize code as elegant, other code becomes sloppy. When we praise efficiency, the notion of waste is born. Being and non-being, simple and complex, long and short, high and low, front end and back end. That's right. The vibe coder builds. And you know, this is the vibe. The work is done and then forgotten. This is why it lasts forever. Well, okay, maybe, but I think what we've seen is that this is not enough, especially for production LM applications. But this is probably how the Spark gets created, and this is probably useful. Start with a prompt, a seed. Use agent mode, obviously, rules of vibe coding. Enjoy the process, definitely. And there's a lot of people talking about vibe coding. The definition is already escaping its original intent. It's not the same thing as writing code with the help of LLMs. If it's on low stakes project, if there's no security issues, if you're not really kind of being like totally irresponsible, like this guy. Guys, I'm under attack. I can't explain why my API keys are all maxed out. I've been building in public on X. It's like, well, okay, bro. Like, that's dope. And then you get all this these books that people are like, stop defining vibe coding in a way that makes people feel like this is our thing too as AI Makerspace. You'll notice not a lot of people are still here. It's because we actually don't care if you just like feeling smart, but you actually don't want to write code. We actually really enjoy teaching developers, and that's a very particular brand of thing to want to do. And if you don't want to code every day, you shouldn't pretend like you want to code every day. That's dumb because you should do something else with your life. Now, can you vibe code your way into some dumb front end as a product manager, and should you be able to? Yes, you should. But don't pretend like you're an AI engineer. That's dumb. And so because you won't like it. You won't even like the job when you get it for 150, 200K a year. You don't want to spend your days like that, then don't. Do something else. This kind of AI-assisted development is kind of the thing we all need to do. Vibe coders are not going to take any developers' jobs. It's just not going to happen. And we can say these fun, quippy lines, but if you don't, use tools like some of the agents that are out there, you should be doing this. VS Code is not the end-all, be-all. You can talk about a lot of what Cursor today is doing, how many people are using it. You can talk about what Devin is doing. And the Cognition team is crushing it. They just raised, $400 million, build the future of software engineering. AI Assist is important, okay? And even last March when we launched Devin, it wasn't clear this would work. But it does work. The AI software engineer, though, it's also not going to take your job. It's like you might be able to leverage it. And of course, Cognition acquired Windsurf. And the whole vibe of the whole time that we've had, even since last year, right? Windsurf, the wave-inspired form in our logo, more than just a shape, it's a feeling, okay? It echoes how ideas move when there's no friction, fluid and forward. This company got acquired for tens of millions of dollars, right? And we did have this year of the vibes. We are seeing these coding agents rapidly accelerate. 80% of the value that's been created in AI, some people are saying, it's just from coding agents. I think that's probably true today. Is it going to be true next year? Maybe, but maybe we're starting to get close to kind of being able to move on from that. Claude Code 8 SDK was recently rebranded to Claude Agent SDK. And it's these tools are crazy. You should know about them. You should be able to leverage them. Yes, vibe coding is part of this. You should know about their brand for coding agents and for AI-assisted development at AI. But this idea of an agent still remains the same. And don't forget about the core principles. It is important to also recognize that when we talk about coding agents, we're talking about agents that write code. And those help us today. And yes, there's sort of levels of this that have historically been things that we need to look at. CLI coding agents, IDE coding agents, web coding agents. this kind of Manus Devon level is starting to get to this kind of, you have an entire software engineering team, and that's cool, but how far away are you from the actual work being done? How far away are you from the scoping, planning, reasoning, coding? How do you pick tools? All these are great discussions to have, but in the end, we have to deliver applications to our users. And we have to build them so they have a way to interact with them as not the developer, and they're deployed in a place where our users can get to them. That might be locally on-prem in front of our boss in our one-on-one meeting. It might also be on Vercel because I don't have any PII data and I can just deploy it to a public available link. And so I want ChatGPT for my company. That's what I want at the end of the day. I've wanted it since it came out in 2022. What it means today is it means a deep research capable multi-agent system with agent mode and all this other crap. But it's still ChatGPT for my company. And I still want that simple front end. To do AI engineering, to actually build, deploy, operate, and improve these, we can think about the stack that we're going to leverage. This is the in-context learning design stack. And this is the one where we're putting all this good stuff in here. We're not going to go into detail on this, but we don't need that many pieces to build an end-to-end app. We can use Vercel. We can use OpenAI Python SDK. We can use OpenAI models. In fact, we've done a lot of this back-end stuff already. And we can deploy a quick, fast API backend. We can do a Next.js front end. All this stuff is like very vibe codable, and that's what we'll see. We can connect users to the data they need. We don't actually need to do RAG. We can do response API, file search, remote MCP servers. RAG kind of comes in up here, as we talked about, right? Data coming in, embedding models, vector DBs, all that's dope. Responses API, got your back. We can also kind of optimize access to kind of tools. Where are we at? Tools, API calls, agents, boom, response API, got your back, MCP. And like, you can also kind of go and now start saying, okay, well, I've got RAG, I've got agents, and I am ready to kind of show this to everybody. The question is, what do you do when you get here? And you can go to Lovable. Apparently, it's going to kill software engineering. That's what I heard. Is that right? It's dead. Software engineering is dead. And you can prompt your way into like a crappy little GPT app. Wiz will show you exactly what you get. You can also go to v0.dev. You can prompt your way into a crappy little GPT app. Wiz will show you. It's fine. You can also like make your own with Cursor, and it's a little bit better. You can give it a little more of the vibes. But at the end of the day, like, don't forget, it's not about vibe coding. It's about delivering, again, I think the real theme of the conference here, real value to our users with applications that create real value for them. And you'll need a front end and back end to do this. So let's wrap it up by literally wrapping it up. Am I right, guys? Here we go, Wiz.
Oh, yeah. Okay, so I'm not going to vibe code in front of you because that's a little cringe, okay? But I can tell you that I've been over there vibe coding. And so the app you're going to see right now was produced during the content we were delivering. Close enough. So first things first, I've already pre-populated it with some responses. Hey, how can I help you today? What is context engineering? This was using research mode. You see we got an emoji you can click. Turn research mode on and off. It took a long time to generate this, to be honest with you. And there was no wheel that spun letting me know it was working. So already we know some improvements that could make this less painful to use. I'll show you an example. Just shout out a topic. We'll send this off and then we'll come back to it. Any topic. What do you guys? Sahar, what topic? How do you vibe code ChatGPT? We're going to use research mode and hit go. Okay, we'll come back to it. The other thing we could do is say, like, who are the authors on this paper? Which makes no sense. What paper, right? I don't know what paper you mean. Can you share the title? But with RAG mode, we can ask the same question. Who are the authors on this paper? we can upload the DeepSeek R1 paper, and we get the whole, look at this, big old list, right? So RAG mode, working. We can upload a single file, and we can use it. And then, of course, hey, how are you? Right, we're going to get a response back. We can click the new chat button to start a new chat. Anyway, this is the idea, right? And this is all producible while sitting over there, just using pure vibes. I haven't looked at an ounce of the front end code. I have no idea what's going on there, but I'm confident it's working because I'm playing with it, right? So that's good. So that's the bare minimum. Let's see if we got a response back. Look at this. Okay. Short answer, set the vibe by being clear about what you want. Give just enough context. Here's a quick practical playbook you can use. Set the working agreement once. Be my pair programmer. Stack, languages. Starter you can paste. You're my pair programmer. Great. Oh, this looks fine to me, right? So this is the idea, though, that you can cobble together all the tools we talked about during our time together thus far into a single... Listen, is it as good as the ChatGPT UI? Definitely not. But was it produced while chilling over there listening to Dr. Greg? Also true, right? So there's a balance. But this is it. This is the idea. So we'll look at some of the code for the first time, and you'll notice that this is the quality. Oh, you cannot see that at all. My apologies. Let me. Oh yeah, you'll notice that the quality of message I'm giving this thing is absolutely atrocious. I'm getting an error. Fix the error, right? That's what I'm saying, and it's working. Now, one thing that I want to be clear about with vibe coding versus vibe engineering, which is not catching on, but versus AI assisted development, is that in vibe coding you just kind of your hands off. LLM's doing all the work. You're doing very little. I cannot even pretend to vibe code because we have things like cursor rules, right? We have markdown files that help us understand, what our system can do, and it's very useful because it helps us to understand what we what we wish from our system. So, for instance, I have this rule, which is always use branch development, always create PRs when the feature branch is done so that I can go back and merge it, right? This is to alleviate the need for what just happened, I've lost everything. Cursor will always create a PR for me at the end of any session, right? These kinds of rules, though this is a simple one, and I would argue literally mandatory. Please use at least this rule if you're gonna step into the vibe coding space. You can imagine building this out quite a lot, getting a lot of very complex rules specific to your project. And tools like Cursor, all of the tools that are useful for this have exactly that. We can also clone rules from other platforms like Claude. We can add project level rules. We can add user level rules. We can add branch level rules. We can do all kinds of extremely fun things, right, when we're vibe coding. My suggestion to you whilst vibe coding is to very quickly, as fast as possible, move away from actual vibe coding and move toward something where you've got a little bit more ability to control with intent. Now, did it produce the app? Oh, you betcha. Did the app work? We just saw it. It at least worked a little bit, right? And that's kind of the idea. Looking through the trace, you can see classics using my CD. It's doing all kinds of stuff. It's being wrong many times in a row. Lots to scroll through. But the idea at the end of the day is that it's as simple to build ChatGPT out of all the tools that we saw as asking Cursor to build it for you. Okay, one more thing. I don't want to go on and on about this, but one more thing to consider whilst you're vibe coding is controlling context. So we don't have to be context engineers all the time, but we should really think about context whenever we're asking our system to do anything. And one of the ways that we can do this is by really liberally using our references. So this is a very simple application, but an example is when I want to know about, say, app.py, right? I can provide that context directly as opposed to making it look through all of my stuff, go on a wild goose chase and find everything every time, right? We still want to make sure that whatever we need to work on is in context. Another way we can do this is by adding things like docs, right, to Cursor's context or Claude's context. You can literally drop markdowns in here and have it reference them through rules. The idea is that you want to provide everything that this system needs to do things well. One thing you'll notice if you just ask this without telling it about Vercel's docs, which is the platform we're using for that, so I can just type Vercel in the terminal and suddenly we have an app, right? Is that it has no idea about Vercel because the last time I heard about it was like 2023 and Vercel's gone through a lot of changes. So we have to make sure that we have docs up to date. Even if you're, again, just starting with vibe coding, these are the simple steps you can take to actually have fun. Now, there's not only terminal-based vibe coding, right? We also have, so this is the app that we created. Okay, I mean, it doesn't look great, but it doesn't look bad. It's close, right? But you can also use tools that more directly allow you to vibe code using something like Vercel, like V0, where we can have a chat to do the same thing. I would say like a much prettier UI, right? Like this is you can't see it too well, to be honest with you, but believe me when I say it's much prettier. We have these pluses, we have all this great stuff, we have deep research mode, we can just click here, okay, that's great. You can also use tools like Lovable to do this. Lovable is another tool that's good for building simple web applications. And all you have to do is upload context of your project, in this case, give it the repository that you're working out of, and then ask it to stitch everything together. And you wind up with an application that, in this case, just doesn't work, which is not very useful, but certainly is closer than when we started. If I could say one more thing about vibe coding, it would really be to very quickly mature out of it as fast as you can. That doesn't mean you have to become a software engineer. It doesn't mean you have to spend 2 years doing computer science courses. It just means that you need to put yourself more in the loop, right? You have to have a bit more control. You don't have to understand every line of code. You don't have to understand the syntax of whatever language you're using, but you should understand the general flow of your application. You should understand generally what's happening so that you can ask good questions about the pieces of code to whatever tool you best prefer asking. LLMs are competition level programmers now. It's not like they can't do the job, but they're very difficult to wrangle into a complex project. The last thing I'll say to prevent harping on about it is you should spend a lot of time preparing to hit go on your first kind of ask of the application, right? You should outline exactly what you want. You should be very clear about requirements, very clear about libraries, very clear about technologies. You should be very clear about what version of documentation you're using, right? And provide access to your agent to that documentation. So you're going to spend a ton of time preparing in the hopes that you press enter once and you get something close to a start. And as you move on, you're going to evolve more and more. But this is the idea. Vibe coding is really easy. You get a cool app. It ties everything we did together. There you go. I've been Chris.
Well, I feel like you just kind of killed the vibe on vibe coding, bro. That was, so apparently it's not as much of the Vibity vibes as I thought. Weird. Okay, guys, it's time to wrap here. Thank you for joining us for an amazing session today. We saw some vibe coding stuff. Don't just vibe code, okay? TLDR, don't do that. If you do, don't pretend that you're doing something else. And if you want to be a developer, then you got to do more. But yeah, you got to be able to vibe code, duh. If you want the slides, get the slides. Hopefully they're useful for you. And if you want the code, get the code. Wiz, one question for you on the vibe coding thing. And we'll do some questions after we officially wrap here. What exactly was your prompt to Lovable or to V0? Was it just, yo, take my GitHub and make me a ChatGPT?
Yep. So it was effectively, here's the repository with the logic that you'll need. Please build a ChatGPT clone. And then I pasted a kind of mediocre screenshot of ChatGPT.
Oh, nice.
And then
classic.
it did its best.
And
absolute
voila.
best.
Voila.
Yeah.
Okay. Amazing. So, guys, we have been AI Makerspace today. As you know, we are on a mission to create the world's leading community for people like you who want to build, ship, and share production LLM applications, the kind that create ROI for people and companies. We have a very cool, very competent community. We like to have fun, but we don't like to screw around and be completely incompetent, right? We like people building, shipping, and sharing in public. We do believe this is the creator economy of the future. We see people all the time changing the game in their own careers, becoming AI engineering leaders in their organizations that they are in today or that they want to be in tomorrow. If we can help you as an individual or help your team out, don't hesitate to tell them to join the Discord. Also, you can find us every single week live on YouTube on Wednesdays at 1 p.m. Eastern, including, that's right, this Wednesday. We went live right before this to talk about this conference, so you don't need to watch that one. But we have a couple more How to Build ChatGPTs coming up. We'll add some features to them, and we are always covering the latest and greatest. I think we're going to scooch one out of the way and cover Agent Builder next week because obviously we have a weekly newsletter that I'd love for you guys to check out. It's called the LLM Edge. We're always building, shipping, and sharing. Trying to encourage everybody else to do the same. And if you're looking to get started with AI engineering, we have a brand new offering for people that are not very ready to get into AI-assisted development, but they actually need help with Git, they need help with package management, they need help with Python, they need help with Cursor, they need help with OpenAI API. If that's you or somebody that you know, this might be a good fit. Typically, we built this because people couldn't actually make it into our AI engineering boot camp. We require that you build something end-to-end before you can enroll in this. This is very competitive in terms of the people that we allow into this, and it's something that we run 4 times a year. We're on cohort 9 starting in January. It's our favorite thing to do. If this is for you, feel free to come up and talk to us about this. If you sign up for the January cohort, it's $39.99. You get free access to the on-ramp, which is just $500. And so if this is something that either will help you out, help your team out, we also work with enterprises and do custom work as well to make sure that the curriculum is not just dialed in general, but dialed in specific to your org and your team. Wouldn't recommend starting with any more than 10 people if you're going to put together a strike team, a tiger team to start getting after it, but you can scale it out pretty well from there. Until next time, guys, keep building, shipping, and sharing. We'll do the same. Thanks for joining us, Dr. Greg and the Wiz. Questions? We got Mic Runner. Ready, break, or just ask questions if you have any. Anybody got questions? Questions? You got a question, Jacobs? Close us out. Oh, wow. Oh, my God. It's so awkward, guys. My secondhand embarrassment is through the roof right now. How about, we got a question up here? I think we got a question right there, right? What's up? How do I join the Discord community? Thanks for the question. We're going to hook you guys up. Keep building, shipping, and sharing, guys. We'll do the same. We'll see you at the conference. Come up and chat with us after. Later, guys.
So, okay, I have some words to put.
Okay, what's up? Drop it.
That's it. I started with zero knowledge almost 2 years ago with AI Makerspace. I joined them. At the time, I was in between job and I was redirected. I was thinking what would be more fitted to my talent, or where is the places that makes me more happy to build, ship, and share. And I found AI Makerspace. It was cohort AI E3, so you can imagine how 2 years ago it was. I started with zero knowledge. I knew about, I was data scientist. I did coding. I knew about Python coding. I knew about making products, but I didn't know anything about generative AI things or so. I started with them. I started building, shipping, sharing. AI E3, I graduated, but honestly, I stay connected with them. With all their Wednesdays event, I took every event as an opportunity to think on top and build something new. And I grew over the time. I joined first to a startup, working for them for 9 months. Then I joined another company, Crestron. It is an electronic company, but build, ship, share during the time I was with them. I know that I was productive for them because the knowledge needs to be made somewhere. We cannot, I just scrambled reading from here and there, but in AI Makerspace, I had to instruct myself to per week, twice, doing the projects, doing the assignments. Every Tuesday, every Wednesday, we had sessions, 2 hours. During the week, we are not by ourselves alone because there are supporters there that even the time has been shared during the week. So sometime you can find the time in the morning, sometime later afternoon, maybe Sunday, maybe Saturday, but they are there to help us to understand. And so from the beginning, we learn to build, ship, share. I was not there enough to build and ship on LinkedIn. Dr. Greg pushed me. Push me.
That's
share,
right. That's
share.
right. That's right.
Finally,
The deep lore. Sahar, close us out. Okay.
And
so
then
what did you learn
I am
from
now
all
with
of it?
JP Morgan, building, shipping, and sharing.
Let's go. Okay, let's go, Sahar. Now, if you are as much of a beginner as Sahar was, I would highly recommend not getting into it unless you are as tenacious as Sahar is and as patient as she is. But yeah, guys, if you want to join the community, we're happy to get you in. If you want to chat about anything, we'll see you around the conference. Enjoy the conference this week, everybody. We'll see you at the Mixer tonight, hopefully. Bye, guys.